research on Savio. Yep, sorry. Welcome to the session of Intro to Research on Savio. We have people here in the room and people here on Zoom. My name is Ray. I work with Research IT to help people with research computing questions. And I'll be giving the first half of this presentation. And Chris in the back will be giving the second half of this presentation. Hi, Chris. And then we also have people online who are doing help as well. Before I start, I just want to say thank you for coming and feel free to interrupt at any time if you have questions. Same with people on Zoom. You can feel free to put them in the chat, or I'll also try and stop if you have questions as well. This is meant to be like interactive and to help you with whatever you need on Savio and research.
Ray, maybe speak up a little bit.
Yes. Before we start, brief introduction. Research IT is here to help provide people with help with your research computing, whether that's data storage or computation on Savio. Us here today are often the first point of contact for people who need help with their research here. We have office hours on Zoom, Wednesday 1:30 to 3:30 and Thursday 9:30 to 11 a.m. Or you can also send in a ticket through ServiceNow to the email there below. We're also hiring, so if you're interested in potentially joining Research IT, talk to us after, or you can find the current job description on our website. An agenda for today is we'll do an intro to Savio and high performance computing, and then open on demand and Globus, and a brief demonstration of interactive computing via Visual Studio Code and also open on demand. And then Chris will do software modules on Savio and job submission using the Slurm scheduler. So let's get right into it. An intro to Savio. Grounding this for a bit, a reason why you might want to use high performance computing is you want access to all of the things listed on the right? You want a computer that runs 24/7 that doesn't need to restart. You want to flexibly access the kinds of cores and CPUs and GPUs that you need. You want lots of storage and you want access to the latest hardware for free. And maybe you want to break free from the limitations of your laptop or your workstation. And so that brings you to Savio. And what is Savio? In layman's terms, it's a collection of really powerful computers that we have access to here at Berkeley. It's a collection of nodes that are networked together and also as well as some really big, fast hard drives. It's good for working with large data sets and or computationally intensive code. And that's the basis of the system that we will be working in here today. Some key terms before I get any further. RAM is basically the working memory of your computer. If you've ever seen an out of memory error on your computer, an insufficient memory, RAM is what causes this. Yeah, CPU is basically the processor, which consists of cores, which each can handle a specific task. Savio consists of many such cores networked together. Storage is your memory for saving files, and then service units or SUs are an abstract measurement unit that we use to track compute time on Savio. So how many service units you're using per task that you want to do. Okay, logistics, access, infrastructure, how to get in, how the cluster is built. Getting access, I'm not going to read this, but basically if you're associated with Berkeley in any way you can get access to Savio, you want to manage your Savio account and access through MyBRC, which is the way you create an account and generate your passwords and stuff like that. After you leave Berkeley, you still have access to Savio, even if you lose like your Berkeley email and stuff like that. And then one thing to bear in mind is that applications for any resource on Savio have to be manually reviewed before they can be approved, which can cause some time lag of about a week or so after requesting an account, but someone will look at your request for compute or accounts. Here is a diagram of Savio. There's a lot to digest there, but we'll go through most of the important pieces on here next. You as a user enter Savio through several main channels. I will cover Open on Demand and Globus today, and then we'll cover Visual Studio as well. And whichever channel you enter through, you'll access one of two different kinds of nodes, whether that's a login node or a data transfer node, which are specialized for different tasks. And through those nodes, you can access different ways of different areas where you can store data, as well as the Slurm scheduler, which allows you to schedule jobs to run on Savio. And those jobs are run on different CPU and GPU partitions, which are groups of nodes networked together. Like I said, we'll go through all of this, but it's kind of useful to see how things are visually laid out. Okay, first thing to cover are different kinds of nodes. So Savio has three different kinds of nodes. The first one is a login node, which is used to access the system. When you're logging in, you'll be automatically put on one of these four nodes. It's used for non-intensive interactive work like monitoring your jobs, basic compilation, managing your files, and stuff like that. For computing, you'll want to use a compute node. Your work might need to be parallelized, or you might need to run jobs that only work on one single CPU. You can request compute whenever you want to submit or run a job on Savio. And then this kind of third last kind of node is a data transfer node, which is a difference from many other clusters. It's used for transferring data from one area of Savio to another area of Savio, or from on and off of Savio, like say from your personal computer or from Google Drive or another kind of computing storage service. Nodes are grouped into partitions. There are multiple different kinds of compute nodes with different hardware specifications. For example, a CPU node or a GPU node, which have different amounts of working memory here. And these partitions have different restrictions and costs. And by cost here, I mean service units. So some node partitions are more expensive to use when you're requesting them for compute. And you can see the associated costs on our documentation. But any job you must submit must be submitted to a partition to which you have access to. So sometimes you can get errors if you're requesting to use a node to which you don't have permissions to do so. And then a brief note on data security. Savio is certified for moderately sensitive data, but it must be requested at the start of the project. You cannot convert an existing project to P2 or P3 like level of security. And if you have working with P4 data, you're required to use the SRDC platform. Okay. Like that was on the right. This was on the right in the Savio diagram, but there are three main kinds of directories on Savio. There's your home directory, which you should have if you have an account. And your space there is limited to 50 gigabytes. It's best used for imported code or scripts or things you need backed up. If you are part of a group or a faculty computing allowance, or if you have condo resources on Savio, you'll have 50 gigabytes or 200 gigabytes, depending on which resource you have access to. This is best used for shared project files or things you need to share with other people or your lab group. And then you also have a directory on Scratch, which is intended to be used for computation. It's faster, but it's not necessarily backed up. All three of these storage types are available from any of the nodes, and changes to any of the files when using one node will be seen on the others. You should generally do computation on Scratch because running jobs out of your home directory can slow down the entire system for you and for other users. And if you somehow run out of disk space, you can purchase that for you or for your group from our storage offering. Before I move on to Open on Demand, do I have questions? Are there questions about anything I have said previously or on Zoom? Yeah, go ahead.
Are you going to share this?
Yes, the slides are in the Zoom link, and I believe we'll be emailing them out after, or we can't do that.
Yeah, they're you can look up the whiteboard or they're in the.
I have a question.
Yeah, question in the chat.
Yeah, so you mean it's not necessarily backed up. In that case, if I'm using a Scratch folder, should I store my my results in my username instead, but not in the Scratch folder?
I think okay, the question was like, if Scratch is not backed up, what you do for results? I think a general rule is to store important things in your home directory.
Well, and often your output is going to be larger than is possible to store in your home directory, and so in that case, Savio does the Scratch storage is not from long-term storage anyway, so you're going to want to copy that data off of Savio onto some other storage that you have access to, in order that you have multiple copies.
Okay.
Other questions? Moving on to Open On Demand. Open On Demand is a web platform that provides easy access to the cluster's resources and services. It's an easy way to manage your files and code, and it's a bit more of an accessible way to access Savio. I'll be doing a live demonstration of the slides, or basically going through what the slides show next. So to access Open On Demand, you go to this link. After registering for an account for the first time, you'll be able to log in through your CalNet ID, which I'm doing now. And it might prompt me for Duo. Oh, yes, it will, even though I did this morning.
Can I see the website?
Yes. Okay, you'll accept the information release from CLI logon, which allows us to share like the CalNet resources with the high performance computing cluster. And then you'll enter Open On Demand, which has a web browser, which I'll step through now. So the files allows you to access any of the files you have on the cluster. So this is entering my home directory now. Here you can open your current path in the terminal. You can create a new file, and you can also view and rename files and folders here through the hot dog menu here as well. You can also manage your files by deleting them or cleaning them up. You can create new files and new directories, as well as upload and download files from your own personal PC. And then you can copy and move files from whatever home directory or any other directory you're in to any other directory on Savio, as long as you know the path. File management. You can see your active jobs that are running on Savio through the job manager. So you can see them here. You can also compose a new job, the job composer, which Chris will cover later. You can access the terminal in your browser here through this clusters, which will open me and put me onto Savio immediately. And then going back to Open On Demand, you can also request an interactive session. So Jupyter, if you've used that for Python or RStudio or Visual Studio Code or MATLAB here as well, through like the interactive apps. And then once you have an interactive session, you can manage them through My Interactive Sessions. Questions before I move on to actually starting an interactive session?
There is a question in the chat. What if the terminal isn't working?
There's many. Okay, the question
Like
was
if it's just a blank white page, they're saying.
Yeah, that would be something where you could send us an email to start a ticket, and we can try and help you out on an individual basis.
Yep. And then a second question, is this the best way to transfer data between a local device and Savio? And is there a limit for file size?
For transferring large amounts of data, you'll generally want to use Globus, which I'll show you after this. For like individual files, I think this is a fine way to do it if you're already on Open On Demand. File transfer limits, I'm not sure. File size limits, you're limited by the amount of storage that you have available. So if obviously you're trying to put something over 50 gigabytes, it won't transfer. In general, for large amounts of file or large amounts of data, you want to use something else like Globus or like a command line tool or something. And then any other questions on Zoom? Because there was a question in the room. Okay, go ahead.
Yeah. Is there a way to see what groups you're a part of?
Yes. So to see what kinds of groups and partitions you have access to, that would be done through My VRC, which is you can manage and reset your like passwords or anything like that. There. Yeah, what's up?
Did anyone from UC Berkeley go to the Globus event? It's happening.
Not sure. I can ask. Yeah.
And then if you start a Jupyter server and don't close it, does it continue to run in the background? Is that like a way to schedule a job, or is that a separate issue thing?
Kind of separate things. I'll show you this in a second, but when you start an interactive session, you always have to put in a maximum time that it runs. And then after you're done with your job, it's generally good practice to delete your interactive session. Otherwise, it will also expire at the end of the time that you requested, but deleting it is a good way to make sure you're not consuming extra units and service units that you don't need.
Or I think in many cases you will be able to reconnect to the same session if you close your computer or something like that.
Was another question?
So I recently got an account. How do I know my password for my account? Oh, sorry.
Yeah, no, you're good. The question was, how do you know your password for your account? This is documented on our documentation, but if I remember correctly, you'll set a PIN, and your password for your account is your PIN plus your Google Authenticator password that refreshes every 30 seconds or something. Yeah. And then once you log on to Open On Demand once, you shouldn't need to do it again. But if you're connecting through some sort of like terminal service, you will need to do your PIN plus the Google Authenticator every time. We can help you with that after, if that's okay. Yes. Okay. Any other questions? Okay. Moving on to interactive, what it looks like when you request an interactive session. So I'm going to request a Jupyter server. And this will look slightly different depending on if you want like RStudio or Visual Studio Code, but it'll generally have these information like slots for you to fill in. You have a job and you can name it if you want to track your different interactive servers. Sorry, do you want me to zoom in? Is that helpful? Is that better? You have any software modules that you'll load. So if you want like specialized software, some of which Chris will cover, you can request any software that you want to automatically be loaded onto your session. Here you'll select which Slurm partition you want your interactive session to run on. Notice that it gives you access to, it lists all the partitions, but I'm not sure if I have access to all of them. So that could be a reason why your interactive session doesn't necessarily run. If you request a GPU partition, I think there are different options that come up depending on which kind of partition you request. And then you'll put in whatever account or project name that you want to charge the service units for, as well as any other options that you want, such as the number of compute nodes, the number of cores, and documentation for every single combination of type of node and cores per node is also on our website if you need a reference, because I definitely don't remember them all. And then the wall clock time is the maximum time that you want your interactive session to run. So if I put 1 hour, mine will automatically expire for 1 hour. I believe the limit is 40 or 80, something like that, hours.
In general, 72.
Yeah, okay. Well, general 72 hours. And then after putting all of this, it should start a session. So I'm just gonna request something cheap. And your session will go from, after requested, it'll go from queued to ready. So queued just means that it's spinning up. And it'll show you how many hours you lost here.
Basically, behind any of these OOD sessions is an actual Slurm job that is being started, and so that the startup time is related to the fact that it's starting a Slurm job.
So queued and then starting. And after, when it's running, it'll show you the time remaining from the whole time that you requested. And then to enter your session, you'll click connect here, and the button will be the same whether you requested RStudio or Visual Studio or any of that. And once you interact in your interactive session, it will look exactly like Jupyter if you run it before on your laptop, something like that. Files here, you'll be able to create a Python code or anything like that. Questions before yeah.
So if I'm running a Slurm job on console, do I get access to all of the different partitions, or is it only like Savio 2 and the debug? Because those are the only like ones that I see on the interactive sessions. But that was a very large list of different partitions.
Yeah, I think I have access to different ones. Yeah.
I was like, that was very, I was impressed. Yeah. Yeah.
So maybe it only auto-populates the ones you have access to. And then, sorry.
Question
Yes.
in the chat, do we need to be on the Berkeley network to access?
No, you do not need to be on the Berkeley network to access Open on Demand or Savio. And then in general, good practice after you're done to delete your session. So it will ask me if I'm sure. Yes, I'm sure. Delete. And it will disappear from the list of interactive sessions. But if your session is still running, you can close your laptop and then come back to it. You should still be able to enter the same session, like go home, etc. As long as your session is still running on Open on Demand. Okay, back to the slides. Okay, I covered all this. Jupyter Server demo, computing, Slurm, it'll start up. Generally good idea to click delete and log out. Sometimes there are temporary files stored on this path. Good practice to generally clean it up periodically, especially maybe if you're running out of storage or something like that. Okay. Any last questions on Open on Demand before I do a brief demonstration of Visual Studio and Lewis? Okay. Slightly more advanced ways to work with and move data. Visual Studio is an integrated development environment for writing, running, debugging code. It's kind of like a step up from running Jupyter in your browser. You can interact with files and directories, and it also includes a terminal. As of 2026, like this year, you can SSH directly in Savio within Visual Studio to edit and run code live on the cluster. And it's also documented on our documentation. And I'll just briefly show you what that looks like. So if you haven't used Visual Studio before, this is what it looks like when you enter it. You'll get a start menu, and nothing will be open. You will have to connect your Visual Studio to Savio, which I won't do here, but it is documented as well, and I can help you do this after if you need help. You can SSH and connect to high performance computing at berkeley.edu. And once, it'll prompt you for a password as well as like the Google Authenticator thing.
You might want to make that bigger if you can. It's pretty hard to see.
How
easy that
better?
is.
Okay. And once you're on the cluster or on Savio, sorry, you can open a folder that it automatically puts you in your home directory, but you can open a folder if you know the path or any of the folders in your home directory. And on the left, once you open one of those, you'll be able to see all your files in this file explorer on the left. And you'll be able to open any Python files or any files in this file editor in the middle. And then you have an integrated terminal as well at the bottom where it's prompting me for my password again, I guess.
Yeah, I don't think it should be doing that. So there might be some configuration issue there.
Yeah. So there's a terminal where you should be able to do any commands that you want to run on the terminal in Savio as well. And then, like people asked about earlier with Globus, Globus is a service that allows you to transfer files from one place to another. It lets you start an unintended transfer and leave or close your computer and know that it'll be completed reliably, so you don't have to sit here and wait for things to finish. Once you enter Globus, will load, and it will put you on this dashboard as well. You can start a task from the file manager where if you want to transfer data to and from Savio, you'll search UCB #BRC, and you'll be able to connect to Savio here.
Maybe you can step back for a second and just orient people about the two separate windows there and what's going on.
Yes, sorry. What you're looking at is the two places that I want to transfer data from. On the left is what I've searched for, which is the UCB #BRC, which is what Savio is named on Globus. On the right, I haven't put anything yet, but it would be whatever I want to transfer data to or from. So basically, I'm searching for like a origin and a destination. So like from Savio or to Savio. It's asking me to re-authenticate. So do that. Oh my gosh. Well. Sorry. Yeah. Okay, there we go. On the left is my home directory. And if I want to transfer or sync to data from, say, my personal computer or Google Drive, I would be able to do that here through Globus to start a file transfer as well. Or I can upload data from my personal computer or any sort of like file management moving stuff. That's generally better than open on demand, especially for large amounts of data or large amounts of lots of small files or something like that. Other destinations for data transfer outside of Savio and Berkeley Google Drive include like I said, your personal computer or cloud storage if you run out of storage on Savio, or if you want to put large outputs somewhere else. I will pause for questions, but if not, we're going to transfer over to the second half, which is like software modules and running jobs on the Slurm scheduler. Yeah, go ahead.
So what's the difference between using a DTN, the DTN, like the node, the DTN node, and then Globus? Because I was using AWS to transfer some files, but I was using the DTN node instead of like Globus, so I'm not sure like what the difference is because DTN did the job.
In general, also Chris, jump in if you want, but Globus is like a GUI, like an interactive GUI, so you can set it up and have it run independently. I don't think there's a practical difference. Like your files will transfer either way. It kind of depends on what you prefer in terms of interacting with transferring your files from one location to another. Does that make sense?
So when you're going through Globus, it is going to automatically connect to the DTN or to do the transfer onto Savio. So the DTN is involved, even though the front end and the interface is through Globus. If you're just using SCP or some other command line command, then you would want to connect directly to dtn.brc.berkeley.edu.
I will.
Okay, so thanks, Ray, for covering the first half. I'm going to talk a little bit about accessing software, and then I'm going to spend the rest of the time talking about how to start jobs and interact with Slurm to start your jobs, monitor your jobs, understand what happened with them, understand why things are in the queue, why they've started, and some tips and tricks along those lines. Okay, so let me say a little bit about accessing software. I'm going to sort of jump back and forth between the slides and a little bit of demo here. So I'm logged in here to the login node. And so at this point, I can do things like module avail, and that's going to show me all of the modules that give me access to the software that's available on Savio. So you can just sort of scan through this and get a sense of what's available. You'll notice that there's software like Python and R. There are a couple compiler tools such as GCC and the Intel compiler tools. And so on and so forth. And so you can sort of look through here just to get a sense of what's already available to you. If you then want to get access to a particular type piece of software, you will do module load. So for example, at this point, if I wrote type Python, it would say Python is not found. And the reason for that is because I haven't loaded a module. And so it's not just available automatically. But I can now do module load Python. And now if I type Python, which basically tell me where is the Python executable that I'm about to use if it's available, it will then tell me, okay, that's the location of the Python executable that I could then invoke. And if I do module list, that will show me all of the modules that are currently loaded, providing the software that I have access to in my current session. So at the moment, those are just Emacs, which is maybe automatically loaded. I'm not sure off the top of my head. And this particular version, 3.11.6 of Python. One thing that can be a little bit confusing is the modules in some cases are nested in a hierarchical fashion. And so some modules are only available if you've already loaded the sort of parent module. So for example, if I tried to do module load OpenMPI to get MPI available to me to do to run MPI-based parallel code, it would say, oh, I can't do that. That module is not available. And the problem here is that OpenMPI is a child of the GCC module, or also you could get it through the Intel compilers as well. So what I would need to do in this case is I could do module load GCC. And now if I do module avail, I should then see all of the modules that are available sort of nested within GCC. And where's that? So those are right. So that now sort of pops up at the top here, which is that nested within the GCC module are all these other modules that are available because I've loaded the GCC module. You'll notice that OpenMPI is one of those. And so now if I say module list, you'll see that GCC has been loaded. And now at this point, I can say module load OpenMPI. And now you'll see that all of those modules, Python, which I originally loaded, GCC, which I then loaded, and then OpenMPI, which is available because I loaded the GCC module. Another handy tool, which there was a mention of it in the output earlier here, is you can always do module spider and then the name of and then some keyword that you're interested in, like MPI. And this would then tell you, oh, how would you go? What modules are related to that keyword MPI, and how do I load them? So this will give you some information about doing that. So examples show you that if I scroll up the top here. I'm a little surprised it's not saying anything about GCC here. Say, so let me back up a step. You can basically unload all of the modules that you're interested that you have available and start fresh. If I now do module spider API, trans. Okay, I'm not off the top of my head. I'm a little confused about why it's not telling me anything about the fact that OpenMPI is available if I load GCC. I'm not going to try and debug or clear my head about this live in front of you. But regardless of that, this module spider command can come in handy. Okay, so a few of the common modules that people often make use of are ones related to Python, ones related to R, PyTorch, and MPI, which I've already talked a little bit about. It's a little bit confusing. We have a couple different modules related to Python. There's the Python module itself, which provides Python 3.11.6. And then there's an Anaconda 3 module that basically provides Python by way of Conda, which I'll talk about a little bit later. That provides some additional sort of more packages than the sort of core Python module does. And also, if you're going to then do anything related to Conda, like creating a Conda environment or installing packages with Conda, you need to load the Anaconda 3 module because that's going to then provide you with the Conda executables. If you want to use PyTorch for deep learning, then it's available by this ml/PyTorch. And then you can load R and a bunch of commonly used R packages by just doing module load and then lowercase r. Okay, any questions about accessing software before I move on to talking about the scheduler?
I know you say maybe you'll talk about Conda and creating environments later, but so you will just load Anaconda.
Yeah, so I'll just show you that now since the question is at hand. So you would do module load Anaconda 3 it is, I believe. And now at this point I can do like Conda list, and that will, for example, show me all of the Conda environments that I have. Conda can be a little bit slow on the system for reasons that I may discuss a little bit later, but so there was a little bit of a delay there. But oh no, this is actually, I guess this is showing all the Conda packages that are available. A little bit confused because I didn't actually. Oh, okay. These are all the Conda packages that are available through this particular Anaconda 3 module. But in any event, the larger point here was that once I do module load Anaconda 3, I can then do Conda create, Conda list, all of those commands at that point. Are there questions?
A couple questions on chat. Can Claude Code and similar tools be used from Savio?
Yeah, you can fairly installing Claude Code or the Gemini CLI or Codex or things like that, I believe is pretty straightforward to do just within your own account. You'll probably end up with like a .claude directory in your home directory. And so you can just install that and then run the coding agent via the command line interface just from the terminal. There was a second question.
Yes. Do we have any advice for managing space with Conda environments? I've found that they eat up space very quickly.
Yeah. So one thing you can do is put the Conda environments that you create in your Scratch directory. That's a sort of common thing to do. The other thing that you sometimes need to do is Conda will basically cache downloaded source packages. So if you like install NumPy, it's basically gonna save a copy of the source code for NumPy of the source package in your home directory, and that can sort of balloon into making up a lot of space. I'm forgetting off the top of my head the exact command, but it's something like Conda clean. And there's information in the documentation about how you can run, I think it's Conda clean, to basically clean out that cache of source packages. But you can also put packages in Scratch, and also you can delete packages. You can put environments in Scratch, and you can delete environments as you go along. And then there was a question here in
I was also asking about downloading software that's not included in a module, but it sounds like you just put it in your home directory or Scratch.
Yeah, you can install it either in your home directory or in Scratch, or if you're part of a group and the group wants to all use the same software, you could install it in the group directory as well.
And Chris, a quick follow-up from the previous question about Claude. It's secure, is the question. Can anybody see your Claude API keys?
Not unless you open up your files. I mean, if they're stored in a file in your home directory, only if you open up the permissions on your home directory would other people be able to see that. Okay, so let me move on to talking about Slurm and job submission. So just as a reminder, going back all the way to that earlier sort of overview slide that Ray showed, basically you're going to have logged in through SSH, or maybe you've gotten access through VS Code, or maybe you're in a terminal and through Open On Demand. Through all of those mechanisms, you are going to be basically on one of these login nodes. And then at that point, you are then going to start a job. Now, if you're doing it through Open On Demand and you're not in the terminal and you start an app like Ray was showing, you're not going to be sort of explicitly using sbatch or srun. But behind the scenes, a job will be started for your OOD app. But if you're doing this sort of explicitly and manually, then you're going to be on a login node, and then you're going to run either sbatch or srun, and that's going to ask the scheduler to give you resources on one or more compute nodes on which you can then run your executables or your code in some fashion. And so the scheduler is then going to look for space on the partition that you ask to run your job on. That could be any one of the Savio 3 or Savio 4 partitions, or we have some older Savio 2 partitions as well. And you'll basically be requesting to use a partition that has the kinds of CPU or potentially the kinds of GPUs that you want to use for your job. So let's go ahead and see what that looks like. Okay, so the first question that you might ask is, well, and this sort of came up before, is what partitions do I actually have access to? So let me show you. You can probably do this through MyBRC. I think Ray mentioned that before, but you can actually do this through the command line and just see what you have access to. So let's go ahead and switch back to the terminal. And what I'm going to do here is I'm going to run this invocation that will basically show me what associations I have, and that's basically showing me what partitions I'm able to run jobs in. So I'm going to say user equals Pechoric. Okay, so this is this invocation. In my case, because I wear a lot of hats on campus and I've been using Savio for a long time in various ways, I have access to partitions under a number of different accounts. So most of you will just see access under a faculty computing allowance, something like this, FC, and then the name of the faculty member that you're working with, or the name of a condo, which is when a faculty member has basically purchased nodes on Savio that people in the group will have priority access to. And those will generally start with CO and then the name of the project or the group. So I can narrow this down a little bit and say, I just want to look at what I have access through a faculty compute allowance. So I'm a staff member who works on IT, but I'm also an adjunct professor in the university. And so I actually have my own faculty computing allowance. And so what I can see here is that because I'm a user who's associated with this particular faculty computing allowance, so I'm the user Pechoric associated with this particular faculty computing allowance, I have access to all of these partitions that are listed here in each of these individual lines. And in most cases, this is fairly straightforward. For example, we can see I have regular priority access to Savio 3. And by regular priority, I mean that there's a QoS, which is basically gives sort of it's called the quality of service. It basically gives the sort of priority level access that you have to a partition. So I basically have normal priority access to Savio 3. And if you're using a faculty compute allowance, Savio normal is generally the sort of priority with which you'll be running jobs. With the GPUs, it gets a little bit more confusing, and so we'll see this a little bit later, but what we see here is through the faculty computing allowance, I have access to Savio 3 GPU, And then these different priority levels basically pertain to the different types of GPUs that are available through Savio 3 GPU. So because of the fact that Savio 3 GPU has a number of different kinds of GPUs, it gets a little bit complicated in terms of thinking about how to submit jobs there, and we'll see that in a little bit. But this is just sort of an indication of that at the level of seeing what types of resources I have access to. Now, if instead I had looked to see what do I have access through a condo, so the statistics department in which I'm a faculty member has a condo in which we purchased some nodes many, many years ago. And so through that condo, under my username, Pechoric, I also have access to these various partitions through the condo. Well, you'll notice that in most of the cases, the only access I have is through the low priority QoS. And this is the basically low priority access. So these jobs are jobs that are preemptible. So you could submit a job through the low priority queue. If other people submit jobs that need the resources in that partition, your job could be canceled. The one exception to what I was mentioning about only having low priority access is what you'll see is that for the node for the partition in which the PI of the condo has purchased nodes in that partition, you will basically have enhanced priority access in that partition. And so the nodes that we purchased through the statistics condo were in Savio 2, which is one of the older generations of Savio. And so in this line down here, what you see is that through this particular condo, I have access to this QoS, Savio stat Savio 2 normal. So this basically gives me higher priority access than the Savio normal access that I was mentioning before. Okay, so any questions about understanding what partitions you have access to before I go on to talking about starting jobs? Okay, so let's now see how we can go about setting up and starting a job. So basically, yes.
Yeah.
I just have a question.
I also have a
Yeah,
question. I can go first? Okay. So what is the difference for the big memory partition? And I would want to get access to that if they don't have it already.
So the big memory partitions in general have nodes that have more memory than the non-big memory partitions. That's not entirely always the case because some of the older generation nodes have less memory than some of the newer generation nodes. But in general, within a given generation, like Savio 3, if it says big mem or XL mem, those nodes would generally have more memory than the partitions that don't have big mem or XL mem associated with the name.
And how we...
Oh yeah, and in terms of access, you should, in general, through a faculty computing allowance, have access to all of the big memory partitions. If you don't, you could write in an email a ticket, and we can look into that. And then there was a question here.
And with that big memory, Savio, like I'm looking at all my partitions, and I have like Savio 2, 3, 4. What was the difference?
So the Savio 2, Savio 3, Savio 4 are the different generations of hardware, basically sort of how long ago they were purchased. And then the full name, which would be like Savio. So within Savio 3, for example, within the Savio 3 generation, there is the Savio 3 partition itself, which is just sort of the regular CPU nodes. There's Savio 3 Big Mem, which has the nodes with more memory. There's Savio 3 HTC, which has the nodes that are scheduled on a core-by-core basis, which I'll talk about in a moment. There's Savio 3 GPU that has GPU nodes. That makes sense.
And if I'm just running, like I'm on demand right now, and if I want to launch, like, I don't know, Jupyter, is there one preferred that I should do, or?
Yeah, if you don't need a lot of memory and you don't need a GPU, then you would generally use, in the case of Savio 3, either Savio 3 or Savio 3 HTC. If you're only going to make use of one or a small number of cores, you should use Savio 3 HTC, because if you use Savio 3, you're going to get allocated an entire node, and you're going to get charged for all of the cores on that node, which I'll talk about also a little bit. Okay, so let's just see what it looks like to set up a job and run it. So if I were going to run a batch job, basically run a non-interactive job in the background where I just ask the scheduler to run this job and let me know when it's done. then I would basically set up a script, a shell script file, and it would look something like this. It'd have a bunch of comments, and these basically relate to what are the flags that I want to use to tell the scheduler information about what kind of resources I want. And then at the bottom, without comments, I would basically say what are the commands that I want to run. And so let me just switch over to the terminal, and we can just look at this live a little bit bigger. So basically, I've said what account I want to use. So I'm going to use a faculty computing allowance that I have access to. Here I'm saying I want to make use of 4 CPUs on a single node. So that's what this is doing. And this is saying I want to use the Savio 4 HTC partition. And then I also need to get a time. So this is saying I'm only going to run for 4 minutes. And then the commands I want to run is, well, I want to get access to Python. So I'm going to do a module load of Anaconda 3. And then I just want to run some Python code. So I'm going to do Python calc.py, and then I'm going to send the output to calc.out. And what does calc.py do? Well, it's just a module that creates a big matrix and does some linear algebra. So nothing particularly interesting there. It's just an intensive enough computation that we'll be able to sort of monitor the job and not have it finish immediately. So what I can then do now is I can say like this, I can add on additional flags from the command line in addition to the flags that I had as comments in the JavaScript file. And so I don't have to. So I could have just done sbatch job.sh, but I can also give it a name at this point. And then I can submit it. And what we'll do is it will give me back the Slurm job ID. And so I can now sort of use that job ID to understand what's going on with the job. So I could say, for example, SQ minus J, and then 336-90854. And this will tell me what's going on with the job. It hasn't yet started, so it says that it's in a pending state. And that might be because there isn't enough resources on the Savio 4 HTC partition to be able to run it. Okay, so this sinfo command will basically tell you how many nodes are available, how many nodes are already used. This actually shows me that there are 112 nodes that are idle. So there's probably just a little bit of lag in starting my job, and it should start pretty quickly because there are plenty of resources available to run the job. So I can do that again. Okay, so what happened there was it was pending earlier. It ran while I was talking at you guys, and now it returned. And now when I go to look for it, it says, oh, it actually already finished. So we can see a little bit about monitoring at this point. And then I'll run the job again so that we can sort of see it live. But what you can do is you should here to be able to copy some commands here. So after the job is finished, some things that you can do are things like this. You can say SQ minus J, and then the job ID, which is this one. Oh, it might actually. Okay, so there was a typo there. It should be S account. And so this will basically show me what happened with the job. It's a little bit confusing because each job, sort of Slurm manages the job by basically having an overall job and then what are these things called job steps. So it can be a little bit hard to interpret, but this basically shows me the memory that was used by the job. So this is in kilobytes. So if I sort of parse this out, it looks like this used about 1.6 gigabytes of memory, and it took 14 seconds to run. So that's what I'm seeing here. Let me go ahead and run the job again. This is now 858. So if I sort of keep doing this, eventually it will probably, okay, so now at this point, I could actually SSH directly onto the node that it's running on. And if I do it fast enough, what I should be able to see is a job running under my account, and it was running using 395% of a CPU. So what was happening here is I requested access to 4 cores. We can go back and see that in a moment. And because Python's linear algebra runs in a threaded fashion, it was basically using 4 threads to execute that sort of large matrix algebra computation that I was doing. And so we could indeed see sort of in real time that that's what was happening. And in fact, we could also have seen in real time that it was using 1.6 gigabytes of memory, which we also saw when we ran the job before, and then looked post hoc at the accounting information for the job. Okay, so Jen, just to remind you what job.sh looked like, this is the place where I said I want access to 4 cores because I knew that this Python code could make use of multiple cores to do the linear algebra that it was using, that it was doing. Okay, questions or comments at this point?
Question, where do we create the script for the batch file?
Yeah, so you can create the script anywhere you want. You can create it on your laptop and then upload it onto Savio. You can create it with an editor on Savio. For example, you could use Emacs or Vim or Nano or those kinds of things. I guess you might be able to create it from within Open On Demand as well. So basically, any way you have of creating text files, code files, you can create it and then add it, and then upload it to Savio or do it on Savio itself.
We've been having some back and forth in chat here, and so I just want to ask if y'all feel like you got your questions answered, or if you want to unmute and ask. If you still have questions, feel free to do so.
Okay, and then for the sake of time, I'll just mention this just through the slides. You can also run this should be wall. This wall command, and with the name, with your job ID, in this case 3456. Sorry, that green is not showing up very well. It will basically show you the number of CPUs and the memory being used by that job. So you can get a sense of usage without actually SSHing onto the node as well. Okay, let's see. So a little bit more about so I just showed you how to run a batch or background job. You can also run an interactive job from the shell using srun. And if you do that, again, I think for the sake of time, I'll just show this in the slides. Basically, what you would do is you'll put all of those flags similar to what we saw in the job.sh job script. You'll put them in the command line here. And then at the end, you'll add this ---- pty bash, and that will then cause you to get a shell session that you will then interact with. The way that you will know that the shell session has started and that you're on one of the compute nodes is instead of having your prompt be something like your username at ln002, you will change to your username at and then something different, which will indicate which of the compute nodes are you actually logged into and able to use. Of course, other ways to do interactive computing are through Open On Demand or through VS Code. So those might be preferable to you compared to just doing things in the shell. This is certainly one possibility. Okay, a little bit more about this notion of per node and per core scheduling, which I mentioned before. Basically, you want to pay careful attention when you're requesting resources that if you're requesting resources in a partition where that is allocated on a per node basis, you want to make sure that your job can actually make use of all the CPUs on that node. Otherwise, you're going to be getting charged for all the cores on that node, even though you might not be using them. So suppose you were doing some computation in Python that can only use 1 core, and you requested the Savio 3 partition, you're going to get charged for all, say, 56 cores on the node, even though your job is only using 1 of those cores. So if you're using only 1 or a small number of cores, you'll generally want to use one of the _HTC partitions. If you are wanting to use the GPU, then of course you'll need to use one of the GPU partitions. In both of the cases of the HTC and the GPU partitions, the amount of CPU memory that you get access to is proportional to the number of cores that you requested. So we ask that you not request a particular amount of memory. If you need more memory, you should basically request more cores. So if you request half of the number of cores that are available on a node, you're going to get access to half the memory that is available on the nodes in that partition. If you request a GPU, you're going to get access to all the GPU memory that's available for that particular GPU or multiple GPUs that you requested. the non-HCC and non-GPU partitions are allocated on an entire node basis. So you request a node and you'll get access, you'll request one or more nodes and you'll get access to all of the cores and all of the memory on the nodes that you were allocated. Okay, so that sort of brings up the question of like, well, suppose I have a condo, I have access to a condo that purchased Savio 3 nodes, and maybe I need to run a whole bunch of tasks, but each one of those tasks I don't know how to parallelize. So one of the ways that you could handle that is you could use a tool called GNU Parallel, and that is basically a way where you can take a whole bunch of independent computations and sort of group them together so that they all run at the same time on a single node or on multiple nodes. And so that would be one way to sort of cheaply or sort of in some sense parallelize your computation by running multiple tasks all at once. So that is a good way to take advantage of all of the nodes that are available on partitions that are allocated on a per node basis like these. You can also run, if you want to be able to start up a whole bunch of jobs at once. So maybe you're doing like a parameter scan and you want to basically run one job for each of a bunch of different values of that parameter. You can use these things called job arrays that basically allow you to start up a whole bunch of jobs at once. And then what they're going to do is when you do something like that and you say SBatch, and then you give the number of jobs you want to run. For example, this would say I want to run 32 separate jobs numbered from 0 up to 31. What will happen is Slurm will basically set an environment variable, this particular environment variable, and then your code could then basically query that environment variable so that it knows which of the different tasks it's running, and then make use of that in your. And then, of course, another way to basically make use of multiple cores on a node is to use the various parallelization tools that are available within languages like Python and R. Okay, so now let me say a little bit more about running jobs with where you have code that will run in parallel. So basically, the Slurm flag we saw before was ---- CPUs per task. And this is what you would use if you want to basically make use of multiple cores on a single node. If you want to make use of multiple nodes, then you can basically say how many nodes you want to use with ---- nodes. And if you want to run, you want to say how many tasks to run on each of one or more nodes, you can use ---- tasks per node. It's also possible to use ---- tasks, which is somewhat similar to ---- CPUs per task, except that if you say ---- tasks equals, say, 4, often all 4 of the CPUs that you would be given are going to be on the same node, but in some cases they might be on different nodes, and so that could interfere with your ability to do the parallelization that you're trying to do. So it can be important to sort of distinguish between these different flags. And what's going to happen when you run a job that uses these different flags is that, let's actually go ahead and do this in a live. So for some reason, I've lost my cursor here, so I can't actually see where I am. Okay, so here's me. Here I'm trying to run an interactive session, and I've requested 4 CPUs per task, so this should give me access to 4 cores on a single node. Hopefully this will start up fairly quickly. So it's been allocated. Okay, so what I can do now is I can say env, that's going to show all of the environment variables that are set in my shell session. And if I grep for Slurm like this, what you'll see is all of the variables that have been set when Slurm starts a job. And so the particular ones that are useful to see here is that, for example, I can see there were 4 CPUs per node available. And that's because I requested that -C4. Here. I can see what node it's running on, so it's running on this particular node. I can see it's using only one node. So basically, these various environment variables are going to be set based on what you've requested with minus nodes, minus n tasks per node, minus CPUs per task, etc. And so the sorts of patterns that you'll might be using when you're trying to run parallel code is you might have a job that you want to run on a single node and use multiple cores or multiple CPUs. So this would be like threaded code with OpenMP, or if you're using Python or R or GNU Parallel to do your parallelization. You might be wanting to run code across many, many cores on multiple nodes. That would often be the case, for example, if you were running MPI jobs. So for this, you would generally use the minus n tasks or the minus n tasks per node. For this, you would generally use the minus CPUs per task. And then there are cases where you might have what we might call hybrid jobs, where you're basically running a whole bunch of different computational tasks, and each one of those tasks can itself be parallelized, for example, with threaded code. So this would be an example of that would be using MPI, where each of the MPI tasks can then do threading within the task. And so if you were doing something like that with a hybrid job, you would generally be setting minus n tasks or minus n tasks per node to say how many of these overall tasks you have. And then you would also say CPUs per task to say how many cores you want to use for each one of those individual tasks. Okay, questions or comments before I switch over to talking about GPU jobs?
It's 4:48. Just let me know.
Yep, I got that. Thanks. Okay, so let me say a little bit about GPU jobs. So the basic invocation, which I'll probably try and do live here, is so submitting GPU jobs is a little more complicated, particularly in the partitions that have multiple different GPU types. So I just want to highlight a few things here. So I'm saying I want to run in the Savio 3 GPU partition. I'm saying, and then I need to say that I want to use a GPU. So that's what I'm doing here with this minus GRES flag. And I'm saying how many GPUs I want to use. And then in many cases, you're going to just need to say which kind of GPU you want to use. So one of the kinds of GPUs that are available, a somewhat older kind on Savio 3 GPU, is the Titan GPUs. And then we require that you request a certain number of CPUs for every GPU that you request, and we listed in the documentation. It happens to be the case for the Titan type. You have to request 4 CPUs for every GPU. So that's what I'm doing there. And then in many cases, you have to request a particular QoS that aligns with the particular GPU type that you're requesting. And so if we had gone back to look at the QoSs that are available to me and how they line up with the GPUs, we'd see that the only way that I can request this particular kind of GPU is through low priority access. So that's why I'm using this minus Q. It happens to be the case that at the moment, at least when I checked an hour or two ago, most of the other GPU types in Savio 3 GPU are already being used by users, except for Titan. So that's why I'm using that as an example here. And so if I do this, that should have worked. What happened there? So it says the job doesn't have a GPU, even though I did say that here. Oh, okay. The reason why is I forgot that I'm actually still on I'm still in my interactive session on one of the compute nodes. Okay, so then it actually kicked me out because of the time limit. So let me try that again now that I'm back on the login node. We only want to submit jobs from the login node. Okay, so it says it's queued, waiting for resources. Eventually, that should become available, and I should be able to then run my code that makes use of. Okay, so for example, I'm now on one of the Titan nodes. If I do NVIDIA SMI, I should be able to see that in this case, it's only listing 1 GPU. There are actually 2 or maybe 4 GPUs on this node. But I'm only seeing one because I only requested access to one. So I'm only seeing that one GPU that I have access to. Okay. All right, so once you're on, if you're running interactively and then you want to sort of monitor what's going on, NVIDIA SMI is a good tool. You can also run GPU stat, and that will show you some of what's going on in terms of the different processes that are using the GPU. Okay, so then I'm gonna sort of wrap up by talking a bit about how the queue works and how we can sort of see what's going on with why jobs may or may not have started running. So basically, in terms of priority, condo jobs generally get top priority, and then FCA jobs get lower priority. Within either condo or FCA usage, the priority that you get is going to depend on how much has been, how many other jobs have been run recently by other people in the condo or other people in the FCA that you have access to. And so there's sort of a complicated prioritization scheme that's going on behind the scenes. What we can do once we have submitted a job is we can then run SQ and try and see if it's not, we can then see if it's started to run. And if it hasn't started to run, we can generally try and diagnose why it might be that it hasn't started running yet. And so I'm going to go ahead and do that live here. So SQ has a whole bunch of different sort of options for what kind of output you want to see. So I'm going to sort of pass a whole bunch of syntax here that will basically say what kind of output I want to show. And so what we can see now is, let's see if I can get this all to show on one line. That's probably not all going to show on one line, but what we see here is these are all running jobs with the R. But if I look up here, there's a job that's pending. This is a job that's never going to start because it's requested more than the maximum wall duration, more than the maximum amount of time that it could run. Somebody requested a five days for a job, and that's more than the 3-day limit. So this job will never start. There are other reasons that a job might not be running. For example, resources generally would mean that you're at the top of the queue, but there aren't the resources available to run your job yet. And priority means that you are lower down in the queue and there are not resources to run your job yet. So that's what you would see in those cases. There are some other things that you might see here. Let me see if there are any that are worth pointing out here. Yeah, so if you see something like QoS group CPU limit, this is associated with, for the condos, and in some cases for the faculty compute allowances, we basically have a limit on basically how many GPUs could be used at once or how many CPUs could be used at once within that particular project. And so this is an indication that basically other people in that project are already using the maximum amount of resources. So we have this all documented, and I've sort of listed here some of the different reasons why a job might be waiting to start or why it might never actually start. But you can sort of decipher those if you look carefully at the documentation and look at the output of this queue. And then just a little bit in terms of troubleshooting jobs that maybe didn't produce the results that you were hoping they would. A good thing to do is to look at the slurm.out and slurm.error files, which will generally have a name like slurm dash and then the job ID, then .out or .error. You can use saccount, as we already saw, to basically see how long the job ran for, how much memory it used. There are some error codes that in some cases might be a little bit helpful. If you find that there's a problem and it always seems to occur on the same node, that might be an indication of a hardware problem on that particular node. And so one thing you can also do is you can use -W and -X when you're submitting a job and basically either try and force Slurm to use a particular node or force Slurm not to use a particular node. And so that can sometimes be helpful for debugging. And then some of the other things that we suggest are to try and run the code interactively to try and see if you can see any useful error messages, or sometimes to just sort of run a smaller version of the job on a single node if you're trying to run a multi-node job and see if the problem is simply the communication between the nodes. If it runs on a single node but not on multiple nodes, that might indicate some sort of problem communication. Okay, so I'll say a few other brief comments at the end, but before I do that, are there any questions about Slurm or the scheduler or running jobs?
I have a question, probably starting further back even, is that if I have some data analysis codes that I want to run and I don't have any sense of how long they're going to take or what capacity I need to actually be feeding this, how do you go about working out what level to feed things in, or how long things are going to take? But I know it's not going to run on my laptop and it's all up, but
Yeah, I mean, so I would, yeah, it's a good question. I mean, one way to approach that would be to sort of do a little bit of a scaling exercise of like start to run your code on a small subset and see how long it takes, and then sort of scale up to the full job. You could, as long if you know it's going to be a huge job, it's often a good idea to sort of do that scaling. If you don't think it's going to be as particularly massive, then you might just go ahead and try and run it and see how long it takes and see how much memory it used, for example. And you might encounter, maybe it runs out of memory and you see that happened, and then you need to know that you need to say request more cores in order to get more memory, or to request some one of the big memory nodes. So those sorts of strategies. Other questions?
If you're like requesting, or how do you know if you're not exceeding like FCA? If I'm running a job, like I paralyzed, maybe I requested too many GPUs or something, would it not run completely, or?
It will generally start as long as the people in the FCA have not exceeded their usage. You can, in advance, if you know you're going to run a job for 3 days that uses 24 cores on a particular partition, you can sort of calculate out in advance how many service units it's going to use. And there's a command called check usage. I don't remember the exact invocation. So you can look in the documentation, and it will show you basically how many service units have been used to date by all the people who have access to that FCA. So you can get a sense of like how many service units is my job going to use relative to what is still available. If you're worried about using a whole bunch of service units, that sort of goes back to the previous question. It's a good idea to sort of start with a small job, see how long it takes, and how many core, and think about how many cores you're going to use for it. So throw through a bunch of service units without sort of efficiently using the resources. Questions? Yeah.
Are there any pitfalls to be aware of when it comes to code, not to step on other people's toes?
Well, your jobs are all isolated from anybody else's jobs. Your actual running job is not going to interfere with anybody else. Okay. The only real concern would be that you're going to burn through service units that are then not going to be available to other people to improve. Or that when you're running a job, for example, if your condo has access to, say, 48 cores on 2 nodes, and you're using 24 of them, then all the other people in your project can only use 24 in addition to that. So you're going to basically be using up capacity at that time other people can't use. Yeah. So you'll worry about that. And then beyond that, it's just a matter of burning up service units that other people can't use. Okay, I think we're basically out of time, so I think I will. Unfortunately, there was some interest in Conda. We talked a little bit about it, so maybe I answered some of those questions. There are some notes here. We have a bunch of documentation, as well as a training from a couple of years ago that's linked to from here that may be useful. And so I think I will probably end with that. And both online or here in person, we're happy to answer individual one-on-one questions if people want to hang around for a little while afterwards. So yeah, good. We're at 5 o'clock, so why don't we formally end there, and we'll stick around if people have individual questions. We're happy to answer.